welcome to the show today, Green Spring. I'm happy to be joined by Richard Schmidt. He's our new cosmology expert on the campus, right? Is expert a good word?
I don't know. It's just something I've been interested in. If that makes me an expert, I don't know.
Okay. You're taking the reins from our good friend Albert Weinstein, who ran the group for many years.
Many years is right.
Yeah.
10 years. This is the 10th year.
And so happy to have you here, on your first cosmology show on Village in Motion. Hopefully we can keep on having you back. So today we're talking about where did we come from sort of a cosmology perspective, right?
That's right.
Okay. So you've got some topics here for us, and I think we're going to start with the solar system, about sort of the beginnings of how all that out there in the final frontier came to be born, right?
Yeah, our last meeting, we presented a video, and it brought out the idea that the Earth came from a gas cloud, and that was the beginning. And this gas cloud, they was wondering, how in the world did it coalesce into a sun and all the planets? And so we went through that. The gravity, of course, should bring that cloud together, but it didn't. Over billions of years, it never came together. What in the world started it to get together? And it was suggested that there was an exploding star somewhere, a supernova, that pressured the gas together and started the whole process of coming together, forming a sun, and then eventually, out of the disk of debris around the sun, the planets would form.
And that they called the Big Bang?
No, the Big Bang was before that.
Big Bang was before that?
Yeah. The starting of our solar system was about 4.5 billion years ago. And the Big Bang was 13.7 billion years ago.
So the Big Bang was the beginning of the universe.
That's right.
Okay, and this is just our our neighborhood.
Our neighborhood of the universe. That's right.
Okay, and you said a supernova is an exploding
Star.
One that's died.
As a star grows older, it runs out of fuel. And when it runs out of fuel, it collapses, and if it's large enough, it'll blow up and cause a supernova.
Okay. So was that supernova pressure on a gas cloud that created our solar system, and the cloud sort of collapsed into itself to form our sun? Is that?
Yeah, as the gases come together, that denseness increases the gravity effect. And so it coalesces into the center, you have a sun, and then around it, the rest of the gas just swirls around that sun because of gravity. And now, in that debris that's out there, you have collisions forming what they said, probably small moons, moon-sized planets. But then those moon-sized planets started crashing together and forming the bigger planets. And so gradually we ended up with the planets we have today.
So it was all sort of became sort of organized chaos after a while.
A lot of
Things
chaos in the beginning.
Grew out of crashing into each other. And
We still have asteroids out there, and they can crash into planets. We have the comets that come periodically, and they can crash into a planet too.
And so, but what made our planets spherical in shape? Because certainly I imagine things that are crashing into each other would have jagged, rough edges and not turn into these smooth celestial bodies that we have now.
We've seen some pictures of asteroids. Those asteroids had collisions, and they're lumpy looking.
Right.
Why? Because they're small. As you get larger and larger and larger, gravity tries to form a sphere. In the beginning, with all these big collisions, these planets were molten, so they're liquid. Well, if they're liquid, they sure can form around, and gravity will try and bring it into a sphere. If you have a bump on this bubble, it's going to come down. It'll flatten. Right?
And all this happened over sort of millions of years. It wasn't like just sort of a quick...
One of the funny things is I just went to the planetarium over at Smithsonian Air and Space, and they said the moon was formed by a huge planetoid hitting Earth, skimming off of it, knocking all kinds of debris into the air, and forming the moon from that debris within 1 month.
1 month, really.
That shocked me. I didn't think anything happened that fast.
Okay, so maybe not millions of years.
Well, most of the planets was many millions
Okay.
of years. Yeah.
It means it's like much like our Earth. So I think, I'm just so excited to make use of our new little model we have here next to me.
Yeah, pretty cool.
So essentially, and because I'm a visual learner, kind of what you're saying happened is all these planets are moving around, and at one point they were, I guess, sort of crashing into each other, and pieces were exploding off and floating elsewhere into space, and eventually all these pieces sort of caught into its gravitational orbit of our star and sort of formed up into spheres. Is that correct? Is that a
Yes,
sort of layman's basic 101, very ignorant theory of it?
I went to Wikipedia to look that up, and a lot of strange things were happening. Like the large planets like Jupiter and Saturn, they suggesting that they were much further in.
Okay.
But they were beyond what they called the frost line. The planets that were close in, Mars and Earth, Venus, and Mercury, was so close in that it was so hot that it burnt off all water, burnt off any gases. They were just rocky and molten. Whereas anything that was so far out that it was cold, that's why they call it the frost line.
Gotcha.
Anything out there wouldn't have that same problem. So we have gassy planets out here. Jupiter's a gassy planet.
Right.
And so is Saturn. And so they formed close in to where the asteroid group is right now. The asteroid group is between Mars and Jupiter. And those asteroids just never got together to form a planet. There's some large asteroids out there, but still not big enough to be a planet.
Right.
And then gradually, these gas planets moved out. So they were closer in, and then they moved out. The planets that were closer in, including ours, also started moving out. And so they weren't in the same orbits that they are today. In the beginning, they were closer to the sun. As they moved out, and other asteroids would come in and crash into Earth, delivering water, water now would not boil off. They were far enough out that it didn't boil off anymore.
And that will come into play later on, too, when we talk about the formation of intelligent life or even microscopic life. These planets here, too close to the sun, it's too hot to sustain life.
There was nothing there to sustain life.
It's almost like it's sort of in a continual boil, and anything living is just going to continue to die off, or not even live to begin with, I guess. But Earth, we're just about in a good spot for, I think this is Earth back here, but we're just in about a good spot for what they call that, the habitable zone.
Yes, it's in a zone where water will be able to be in all three states, solid, liquid, or gas.
It's all very interesting. And don't we have another neighborhood outside Pluto or about with Pluto? The rocky ice planets, that's where it's cold enough to
the Kuiper Belt is what
freeze.
you're getting
The
to?
Kuiper Belt, that's what it is.
In the Kuiper Belt, of course, I'm not that familiar with it, but there's a lot of asteroids out there as far as I know, or comets, and they will come into the solar system, in the interior part of the solar system, pulled in by the gravity of a passing planet.
Okay. And so, back on the farm, the beginning of our solar system, what's next for us? You've got chemistry and carbon and whatnot.
Yeah, after you have formed this Earth, you've got an Earth with water on it. You've got a lot of molecules on it that could have come in from asteroids that have come by. They could crash into the Earth and deliver molecules. You have a lot of basic elements. And the real basic elements that build into life is carbon, hydrogen, oxygen, nitrogen, and there's another one. It's phosphorus. I couldn't remember the phosphorus.
And are all these elements found out in, like when they talk about nebulas, kind of like what we're seeing on the screen, and groupings of stars, those elements also construct those, I don't know, are they masses
Well,
or
hydrogen
bodies?
is the beginning.
Yeah.
When the Big Bang occurred, mostly hydrogen was there and helium. These are the lightest elements. And they combined in suns. As suns were first formed, those suns would take hydrogen and through a nuclear process turn it into helium.
Okay.
And as the helium and the hydrogen would burn up, they would turn into even more dense elements, or higher on the periodic chart, the chemical chart. And so that's where all these higher elements came from these exploding stars blowing out these elements into space.
So essentially, we're all made of space matter as well.
We're all made out of stardust.
Be a good topic for a science fiction novel.
Mm-hmm.
Not even,
I'm sure it's been there.
yeah, sure, you're right.
Yeah.
Okay, and so all these elements sort of came together and formed sort of our cell membrane.
Now
or
that's
a
the
cell
trick.
membrane.
How do you bring these elements together to form cells, living cells? And so scientists have been working on that, and they've discovered that they can produce part of a cell. They haven't got the whole thing down, but they've discovered how to do a part of a cell, and they think they're on the way to get the whole cell. They've also discovered that in nature, the same things that they do in the lab can be done in nature. That it's not something that's only done in the lab. Through natural forces, it would happen. In addition to the way they have done it, they have found that nature has another way of doing it, and that's in these volcanic vents at the bottom of oceans.
Oh.
Those conditions down there also will generate the beginnings of cell material.
Okay.
And after you get the cell material, that material has to get together and form the cells.
So are you saying that even today at the bottom of the ocean, there's vents that are creating cells for us?
Not creating cells, but creating the chemicals that can form the cells.
In the beating heart of our planet or something like that. It's kind of what it sounds
you
like.
You could say that. Sure.
Okay.
Sounds good.
So anyway, continue.
All right. Now after you get a cell, you have to replicate that cell. Otherwise, forget it. You got a one-time thing. But in replication, you can carry on new things. If the cell improves in some way, it can pass on to its descendants all those improvements. And that's what was going on. You started out with a single cell, and it had no nucleus. And that lasted for many, many years. Well, then you came out with a more advanced cell that had a nucleus. The nucleus had a little space inside of it that brought together very vital things. And so it would pass that on to its descendants. And then later on you had multi-cell created. So it gradually grew till finally you ended up building what we call living things today. Trees and plants. Of course, they didn't start out as trees. They started out as moss or algae. Okay, very simple things. And then finally evolving into something more complex like a plant. The same with animals. From those same cells, those cells could migrate into something that would be bacteria. That's one of the first things that came out was bacteria. But after that, we had cells that came into animal life, or what we would call animal life, very primitive at first. Just like the moss was very primitive, we had very primitive animal life growing into more complex life. And the whole basis of that was DNA.
Right.
DNA was how to program what was going to happen next in that descendant. That descendant would carry on the characteristics of the parent to the child. The other thing that you needed was that cell membrane to keep things outside from affecting the things inside.
So a protective layer.
Yeah. Things that were inside was going to produce what that cell could do, but you had to stop the interference from chemicals on the outside.
Right.
And so we had a cell membrane and then this DNA memory. Those two things together produce life.
And eventually intelligent life. Like that's
Eventually intelligent life.
It's always been a big
we're
mystery
intelligent.
to me is like how did, and I'm not expecting you to be able to explain this, but you know the way human cognition works with memory and you know the way we rationalize things, where all that grew from, and you know what sprouted all that.
Well, it's what we call a self-organizing system.
I guess, yeah.
And I work in artificial intelligence, and that dwells on that topic.
Do you?
Yes, I do.
I did not know that.
Yeah.
Okay.
And so I've come up with an equation for intelligence, and it has proved out. And
Okay.
I've built systems built on it.
Is this going to be like an equation that's going to rival something like a IQ test later on down the road?
No,
or-
it's how you can build intelligence into a machine.
Okay.
And so I use that to build intelligent machines.
Well, then maybe you might be able to explain it. Give it your best shot. How did we grow from being, sort of just regular non-thinking cells into these intelligent beings that we are today? What's your...
Well, when you start
take?
with this small animal thing, it can move around. Well, if it gradually senses things and works in a proper way to protect itself, that's going to be an advantage. If it's an advantage, it passes it down to its descendants.
Is that almost like natural selection?
It certainly is.
Kind of, okay.
Right? Because those that don't gain that same intelligence will die out.
Survival of the fittest.
Right.
Okay.
The ones that gain that intelligence will survive.
Okay.
And so you gradually build up that intelligence, and new things happen, like the eyeball. I mean, the eyeball, that's a phenomenal feature, but it came out from just being able to sense light, and sensing light was beneficial to these original cells, and they would move towards the light if that was beneficial, or away from the light if that was beneficial. As long as it's beneficial, it would help that cell have descendants that would last longer,
Okay.
have more descendants. Okay?
So once again, it's just sort of this randomized chaos, almost like this natural sort of guess and check, and the things that worked would continue, and the things that worked wouldn't continue.
Unfortunately, it still goes on today. You have diseases
Right.
that are caused by mutations. And these mutations are not good. They cause disease. Right? But good mutations carry on and improve the species.
Okay. And so I'm interested in what you have planned for next when you talk about, the evolution of how we came to wear clothing or live in dwellings and
You know,
such.
that was a funny one.
Uh-huh.
When I first saw this program on TV, they said lice was involved.
Yeah, and
I was saying,
when I saw
"Come
that on your
on,
notes, I
what's
was
that?"
thinking,
Yeah.
I never guessed that lice would figure into the creation of our solar system or
But see, in science, you really don't care what you're dealing with.
Uh-huh.
You want to find out answers to questions. And if you can find answers through lice, you study lice. And that's what they did. They were trying to find out, when did we lose our hair? If we branched off from chimpanzees, we still had hair all over our body.
Yeah, some of us still do.
Yes, to a lesser extent than
extent.
a chimpanzee. But at least they wanted to find out, when do we become hairless?
Uh-huh.
And head lice had been around for a long, long time. They were on the gorillas, they were on the chimpanzees. Gorillas had a different kind of lice, but there was two kinds of lice. And they found that this head lice didn't really work with the gorilla lice. And so when it was found that the gorilla lice was coming into the fossil finds on humans, they said, well, it won't work. You'd have to be hairless for that to happen. So if the head lice had hair to work on, and the gorilla lice was in the pubic area, and it was all no man's land in between, no hair at all, they could coexist.
Okay.
And so they assumed that if there was both lice evidence, then they must have had no hair at that time. And so they went back to a certain point and says, you know, that's the time that we must have been hairless.
Okay.
And then they traced down and they said, well, we had this head lice migrated into something else. They morphed into another kind of lice, clothing lice. Oh, clothing lice?
So there must have been clothing.
Must have been clothing. And that came about like 170,000 years ago. They do all this through genetic checking. They go to the DNA and look to see when there's a split between two species. And so you have a hair lice species, you have the clothing lice species, and you can, because the mutation rate is a constant, pretty much a constant.
Right.
You can see that these mutations were occurring right around 170,000 years ago.
Okay, we've actually been neglecting the little graph you have to illustrate this, but maybe if we can use your visual aid, you can point out to us just about when this time was occurring, you know.
Right. Now, you pull a stunt like that, it's not going to show up on our graph because this is a graph taking you right from the beginning of the formation of the Earth.
Right, and it brings
so
us
the
up
full
until
circle
today.
is 4.5 billion years. And if you look at the very top of the graph, it says we've only been here 2 million years.
Okay, so the lice were within that.
The lice is in that
period.
little tiny slice. You're not going to be able to
tiny
see
slice
much
right
there.
at the top.
Yeah.
Oh, okay.
What you see on this graph is as you go around from the top part of the graph to the right, there's bombardment of the Earth, of many moons coming together, forming the Earth. And then as the Earth has formed its large amount, it is hit with smaller obstacles that build up the Earth even some more and add water and add some atmosphere to the Earth. And as you get around, that's only the first quarter of this chart. Life can't start until that time.
Until the heavy bombardment ends.
After that bombardment ends, because up until that time it's like molten Earth, hot, nothing there for the life to be sustained on.
And what do we mean by heavy bombardment?
Of these large asteroids hitting the Earth, or comets hitting the Earth, any of these extraterrestrial objects hitting the Earth, just blowing big craters and devastating things.
Okay.
After that, when things calm down, now you could start to have some life.
Okay.
And as we pass further on, I see here a note that photosynthesis starts maybe about 1/4 way around the circle.
Okay.
And so these single cells are starting right after the bombardment ends, and that's that first curve that's going around the outside of the circle. And a little ways along is when photosynthesis first started.
And can you pronounce the name of that period? It's a rather, I don't know, almost archaic sounding.
You mean
word.
This one down here?
Let's
I
not
don't know
worry
if I
about
can
it.
read it. It says Archean.
Yeah, okay, so it's close.
So in the Archean area, the photosynthesis begins.
Okay.
And so we only have single cells all around. That's that first curve that's coming around. And then you'll see a second curve starting in the lower left quadrant. And that one is, we listed up on the top as the cells that have the nucleus inside them. So up until that time, you have no nucleus in these cells.
Okay.
It's very, very simple cells.
And that's when you were talking about the empty space in the middle of the cell.
Not an empty space, just there's not a combined area for just the nucleus.
Right.
The DNA is just floating in there by itself. Now you see the DNA inside a nucleus. And that carries along for a while, and then you'll see a third track starting. That third track is listed down as multi-cell life.
Okay.
So you have single cell without a nucleus, then you have a single cell with a nucleus, and now you have multi-cells coming, and you don't end up with any higher life until you get up into the upper left-hand quadrant.
Okay.
You get up there, and now we're saying that animals are starting. Animals, and then we see land plants starting later on the next one. Well, that was sort of surprising that
I would be
land
surprised.
plants came after animals. I always thought it was the other way around.
Especially since the animals would maybe need to eat the plants
Yeah.
in order to help their
What was
survival.
going on
right?
here? Well, it's in the definition apparently. When I read another source, it said, well, the plants really were back here with the animals, the very first animals. There were some plants then too, but they were like moss or something very primitive,
Right.
algae, and they didn't consider them as part of the plants. I think they're noting here is when you had larger plants, like a tree or bushes, things of that nature. That started later on.
Okay.
And then you get up to the very top there. The last line that you can see coming in has a little curved area, including the period that the dinosaurs were on the Earth.
Which would seem like a huge amount of time, but it's such a tiny little smidgen
It's
on the
millions of
graph.
years. It's a couple of million years. But on this, where we're talking about 4.5 billion, it's a small amount. And then you get down to humans, 2 million, you can't even see it.
And so lice, you were saying, was happening within that
Caught in there,
tiny little
too.
dot of human. Okay, I'm sorry. I thought
Yeah.
if we brought it up, you could actually point it out, but it seems you need a
Nope.
magnifying glass to see
Yeah.
the place where we existed.
Yeah. Humans have been on the Earth just a fraction of the time that Earth has existed.
Uh-huh. And so it looks like your last point here was that just then identifying the clothing lice means that clothing allowed us to migrate to colder.
Yeah, we could get to colder climates.
Uh-huh.
Now, one of the puzzling things is they were saying, well, that happened 170,000 years ago, yet I found another reference to Neanderthals going up into Europe 500,000 years ago. So we have a feeling they had clothing.
Yeah.
And so there must be some more to be studied in this area. And we're learning all the time. A lot of these things are fairly recent discoveries.
And I had a cheesy line planned for the end of this show because, believe it or not, we're out of time.
Okay.
But I was going to say, and we're going to continue to evolve here at Green Spring.
Absolutely. There you go.
Thought that was a
Very
good
good.
line. Okay, well, thanks for coming on, Richard, and I hopefully we
Okay.
can have you back. This was certainly informative and a lot of fun, and I appreciated you letting me play with my new toy over here.
Okay.
Okay?
So we'll see everybody on the 13th of July. We'll
Yes.
have our next meeting over at Town Center
Okay.
in the music room. And everybody's welcome. Come early, though, if you want to see.
Do you have a topic planned?
Yeah, it'll be 400 years of the telescope. How do we find all this stuff about cosmology? With the telescope.
Telescope.
Great instrument.
Okay, well, that sounds good.
Okay.
Thank you again. And